Hello everyone and welcome to hypothesis testing for the mean standard deviation known z-test, where we are going to go over 3 separate examples, and altogether these are the 4 different options that will happen when we get a word problem. So option 1 we went over in the last lecture video, option 2 and 3 we're gonna do in this lecture video, and if we have time we'll do option 4, but I may have to create another separate lecture video. But let's just jump right into this next example. A school claims their average enrollment each year is less than 1,475 students. In the last 26 years, the average enrollment was 1,468 students each year. Assume the population is normally distributed with a standard deviation of 29. Can you support the school's claim at A equals 0.10? Okay, what's the question? That's the important part here. We want to see if we can support the school's claim. So we need to test the school's claim. What is that claim? That claim is that the average, and it doesn't specify, and we're always just going to assume it's talking about population average or population mean, is less than 1,475 students. So their claim that we need to test is that mu is less than 1,475, or to say it abbreviatedly, 1475. Now we're looking at the last 26 years, which means our sample size is 26. And it tells us in the last 26 years, the average enrollment was 1468. So X bar, sample mean, is 1468. And then finally, the population is normally distributed. Again, that's just telling you information you need to know. And then we have a standard deviation of 29. Population specifically because it assumed the population and it's a run-on sentence. And so we still assume that we're talking about population standard deviation. Now, once we have all our information from our word problem written down, we say, okay, I need to test this claim. Well, what is this claim as a hypothesis? It is an alternative hypothesis. Why? Because this does not include an equal sign. Again, at this point in the lecture, you should be able to tell me that. When I say why, you should be able to answer that. It's metaphorically, right? Because you're not face to face with me, but you should be able to answer that, right? If you can't, write it down on a note card, study it, just like I said in the previous lecture video. So why is it the alternative hypothesis? Because there's not an equal sign there. And so our alternative hypothesis, H sub A, is that mu is less than 1475. That is our claim. That is a less than claim, which means that we are working with again, you should be able to tell me at this point, we are working with a left-tailed test. Okay, so since it's a less than, we are working with a left-tailed test. Each hypothesis test needs 2 hypotheses, the alternative and the null hypothesis. So what is the null hypothesis? Well, it's the opposite of the alternative. What's the opposite of less than? Greater than or equal to. So the opposite is that mu is greater than or equal to 1475. Now, let's draw a picture of what our left-tailed test is going to look like. To be left-tailed means in our normal distribution, we have a rejection region on the left-hand side that is cut off by some critical value. What do we know about this rejection region? We know its area comes from alpha equals 0.10. So what we know is that the area, notice, compared to z critical, it's to the left of z critical is 0.10. And then how many decimal places should we round area to? 4, and so put 2 more zeros. Now I have area to the left and z critical. Again, you should be able to tell me exactly what we should do based on me telling you those 2 words. Area to the left and z critical means we need to go to our chart. So we go to our chart and we find that the critical value that corresponds to an area to the left of 0.1000 is negative 1.28. Give me one moment. Doesn't seem like my pencil is working here. Okay, there we go. Negative 1.28. So again, what is this region called? It's called the rejection region, which means if my z-score that we're about to find is in this rejection region, we reject, what do we always reject? The null hypothesis. And so we say if RZ is less than negative 1.28, that means we are going to reject the null hypothesis. All right, now what do I need to decide whether we reject? We need this Z, okay? We can't compare Z to anything if we don't have Z, so let's go and find the Z. Z is equal to our sample mean. Again, you should know that formula by heart at this point, which is 148. Sorry, that should be 1468. Minus 1475, which is the population mean, divided by the population standard deviation, which is 29, divided by the square root of the sample size, which is 26. When you put that in your calculator, you will get a value of, I'm going to do that real quick. You can pause the video, but I'm having to put it in my calculator anyway, so either way, you will get a score of negative 1.23. Where does that lie in this normal distribution? Well, negative 1.23 is less than negative is greater than negative 1.28. So that means it's in this area right here. It's not in the rejection region, which means we don't reject. So since it's greater than negative 1.28, we say we fail to reject. And what are we always rejecting or failing to reject based on the test? H naught, the null hypothesis. But although that tells us a lot, that we failed to reject the null hypothesis, our conclusion should be about the claim. Again, when I say that and I leave a pause, you should be able to tell me what I'm about to say. So what we care about in our conclusion is the claim. I hope you said that with me. Otherwise, that's kind of pointless. But it's the claim, okay? And so the claim is that the alternative hypothesis. Well, if I can't reject the null hypothesis, that means I can't support the alternative. So we say there is not enough evidence to to support, because we're talking about the alternative hypothesis, so either support or not support. And in this case, there's not enough evidence to support. And just as a side note, at alpha equals 0.10, the school's claim that the average enrollment is less than 1,475 students each year. And that is our conclusion. All right, and that's all we wanted. Can we support the school's claim? No, there's not enough evidence. That's it. We're done. Let's move on to this next example. A youth program claims that on average they have 50 students attend their weekly meetings. Over the course of 52 weeks, a study found that on average 52 students attended the youth program's weekly meetings. The population standard deviation is 15, and again, assume normally distributed. Can you reject the youth program's claim that alpha equals 0.01? So what do we want to do? We want to see if we can reject the youth program's claim. So we want to test the youth program's claim. What's their claim? Their claim is that on average, they have 50 students. So their claim is that the average is equals 50 students. So their claim is that U equals 50. That's the claim we want to test. Now, just to have it down, what does the rest of this word problem tell us? It tells us that we took a sample size of 52 weeks, found a mean of 52 students, and that the population standard deviation was 15. And then now we need to conduct our hypothesis test. Well, to start a hypothesis test, we need to state our null and our alternative hypothesis. Well, we know we're trying to test this claim. What type of hypothesis is this claim? Well, since it includes an equal, it is a null hypothesis. So the null hypothesis is that mu, the population average, is 50. So what is the alternative hypothesis? Well, the opposite of equals is not equals. So the alternative hypothesis is that mu does not equal 50. This H0, our null hypothesis, is our claim. It is an equals hypothesis, which means we are working with a two-tailed test. Let's draw a picture. We have a normal distribution. To be a two-tailed test means we have two rejection regions. We have a ejection region to the left and a rejection region to the right, each which has their own cutoff. Now, what do I know about these rejection regions? I know the area under them is alpha. We are looking at alpha equals 0.01. So alpha equals 0.01. Well, that's the area under both. How do I find the z critical values? I need to know the area under one side. 0.01 divided by 2 is 0.0050. Be very careful with this. I see a lot of you put 0.0500 or mess it up. Use your calculator, okay? And make sure you write down what your calculator tells you. Even I see some people use their calculator and they still write down the same thing. So you have to be really careful, because if you get this wrong, the rest of your problem will be wrong. Because we know whatever this critical value we get, we are going to compare our z-value to. And if we have the wrong critical value, we'll possibly have the wrong conclusion. It's likely that we will have the wrong conclusion. Okay, so half of 0.01 is 0.0050. So now what we know is that the area to the left of our negative critical value is 0.0050. So what does that make our negative critical value? Again, we're given area to the left and critical value, so what should we think? Go to the chart. Go to the chart and find this area inside. You'll find that the critical value that corresponds to it is negative 2.575, which makes the positive critical value positive 2.575. And then again, we want to write what our conclusion is going to be based on how our z-score compares to this. Well, if it's in the rejection region, we reject our null hypothesis. So if z is less than negative 2.575 or z is greater than positive 2.575, we will reject. And what are we always rejecting or failing to reject? H0. Okay. Now we need to actually find our z-score. What are we comparing to negative 2.575 and positive 2.575? The z-score. The z-score is the sample mean, 52, minus the population mean, 50, divided by the population standard deviation, 15, divided by the square root of our sample size, which is 52. When you put that in your calculator, you will get a z-score of 0.96. Is that in the rejection regions? No, it's between negative 2.575 and 2.575. It's in here, which means it's not in the rejection region, which means we fail to reject, or we don't reject H0. But again, this is important, but is that our conclusion? No. What do we care about? We care about the question. The question says, can you reject the youth program's claim at alpha equals 0.01? So can we reject our null hypothesis? Well, what did we just say? We failed to reject it. So our conclusion will be there is not enough evidence at alpha equals 0.01 to reject. There's not enough evidence to reject, so we can't reject the youth program's claim that on average 50 students attend their weekly meeting. And that is our answer. Okay, I do believe I'm going to have to do this last question on a separate lecture video, but let's just look at what we've had so far. We've had that our conclusion is we reject H naught and our claim is H naught. Excuse me, I just noticed on that first problem we did, we said we reject H naught. Oh, wait, never mind. Okay, so first option, we reject H naught and our claim was H naught. So what did we do? We said there is enough evidence at this level of significance to reject the claim. The next option was we failed to reject H naught and the H sub A was our claim, in which case we couldn't reject H naught, so we can't support H sub A, i.e. the claim. And then this last one, our claim was H sub naught, we couldn't reject it, and so we say there is not enough evidence at that level of significance to reject the claim. All right, we're going to see the last option in this last lecture video, so go ahead and move on to it.